Today we go through the concept behind uh, diffusion potential and equilibrium potential. Let's have a look at diffusion potential. Now, the diffusion potential is not very different from the concept what we understand for the membrane potential. Now, diffusion potential is a concentration difference. Basically, it is created by a concentration difference by an ion across a membrane, and the membrane should be permeable to that ion. It means that unequal distribution of the charges occurs across the cell membrane, and those unequally distributed charges tend to align across the cell membrane, and that give rise to the potential that has capacity to perform the work. So diffusion potential is not different from membrane potential. However, the concept of the diffusion potential is such that the ion can be diffusing through the membrane. So let's have a look at this diagram. Here it has been shown there is something known as equilibrium potential. But let's forget about that in the first place. So we begin here with the concept of the diffusion potential in this diagram. Now here, say for example, the potassium which is inside here in the ICF has the capacity, because the cell membrane is permeable to it, to move out into the ECF. And you can see that there are some anions which are not diffusible through this plasma membrane. These anions are basically the proteins inside the ICF. Now when this potassium, which can diffuse out into the ECF, can carry the positive charges. As we know, the potassium is basically cation, and it has a positive charge, and it can move through the plasma membrane out into the ECF, and hence can bring about the positive charges outside in excess, so that the unequally positive charges tend to align. I mean, those positive charges which are in excess and in the ECF, as we know, the ECF has more of the positive ions, that is sodium, and these positive ions can remain unneutralized by the negative charges present in the ECF, as they will be these positive charges will be in excess. So these positive charges can, however, build up in the time course of this diffusion of the potassium out from the into the ECF from the ICF. Now these positive ions in fact can create some potential. Okay, now this is what we understand as the diffusion potential. So if there is a concentration difference for an ion across a membrane, and the membrane is permeable to that ion, a potential difference is created, and that potential difference is known as the diffusion potential. So you can see that the potassium which will be in excess in the ICF can get diffused out into the ECF, because this plasma membrane has the permeability for these potassium ions, and hence the potassium is in excess in inside, and concentration gradient favors the potassium diffusion out into the ECF, and this is what creates the potential difference. Okay, however, we see that for the the potassium, there is another concept known as equilibrium potential as well. Now what is this equilibrium potential? Now equilibrium potential, however, is the distribution of this positive ion, the potassium ion in the ECF creates the environment, the what you say as potential in the ECF, so that the potassium which in fact basically has to come out, because the potassium is in excess inside the ICF, still cannot. Okay, this potassium still cannot come out despite there is a concentration that is favoring the movement from inside to the outside. Now, why is it so that there will be an abrupt stoppage of the movement of the potassium downstream from the higher concentration of the ICF to the lower concentration into the ECF? Why is it so? Now, this basically accounts for the concept of the equilibrium potential. Now, what is it? So, we understand now that the equilibrium potential is basically the potential created by the diffusing ion across the cell membrane in the opposite side of the membrane, so that these ions which were diffusing from higher concentration, lower concentration now will no longer diffuse towards the lower concentration compartment. Here in this case is potassium that is moving from the ICF to the ECF, and it will no longer diffuse now for some reason, and this voltage at which this potassium ion will stop moving from higher concentration and lower concentration is known as equilibrium potential. Now, what is that? It means that there is a potential that equilibrates at that particular voltage, and this is what we say as the equilibrium potential, and it differs from the diffusion potential, and this is the one that decides that the voltage of the particular ion, if are allowed to move through the plasma membrane, always determines its one potential, and that's known as equilibrium potential. For potassium, it has been calculated that it will be a minus 90 millivolt equilibrium. That is, when the potassium will be allowed to move from its higher concentration to its lower concentration, then it will stop abruptly, despite the concentration gradient would not have been equilibrated, but there will be a voltage equilibrated. Okay. Why is it so? Because the potassium are the positive ion, and the ECF has a lot of positive ions, and these potassium ions, which creates the positive potential outside in the ECF, in fact will stop the potassium to come out from the ICF to the ECF, and hence this, at what voltage the potassium stops, accounts for particular voltage inside the ECF, and inside the ECF when you measure the voltage, then that accounts for minus 90 millivolt, where the potassium should have been continuously moved out but cannot. That because of this positive ion repelling the movement of the potassium ion itself. But there is another factor that also comes into play, and what is that factor that comes into play is that these anions, that's proteins which are in excess in the ICF, in fact also attract these positive ions which are unequally distributed now towards the other side of the cell membrane here outside in the ECF, attracts them towards this, and this also helps in the stoppage of this movement of the potassium ion out from into the ECF from the ICF. Now, this is what I hope that you have understood what exactly is the equilibrium potential. So let's have a look at the definition. The equilibrium potential is the diffusion potential that exactly opposes the tendency for diffusion down the concentration difference. So it's quite clear. What is equilibrium potential? It is basically the diffusion potential which opposes the tendency for diffusion down the concentration difference of that particular ion. Here in this case, as we saw, was for the potassium, that the potassium should have continuously moved out despite there is a concentration difference, because potassium is in excess in the ICF than the ECF, but the potassium however will stop at some particular voltage and cannot equilibrate through the concentration, and that potential where the potassium stops moving from the higher concentration towards the lower concentration compartment is known as equilibrium potential, and this is what we see. Okay, so there will be no further net movement of the potassium occurs when the inward electrical gradient exactly counterbalance the outward concentration gradient. I hope that this video has this short video clip has helped to understand what exactly is the diffusion potential and equilibrium potential from the topic of the bioelectricity in medical physiology. Thank you for listening.